Hello, and welcome to PodRocket, a web development podcast brought to you by LogRocket. LogRocket provides AI-first session replay and analytics which surface the UX and technical issues impacting user experiences. Start understanding where your users are struggling by trying it free at logrocket.com. I'm Noel, and today we have Andreas Rossberg, programming language researcher, designer, and engineer. We're here to talk about WebAssembly 3. How's it going, Andreas?
It's going good. Thank you. Thanks for having me.
Of course. Why was WebAssembly 2 a leap forward? And then what does WebAssembly 3 kind of bring on top of that?
Yeah, WebAssembly 2, the primary thing it brought to the table was vector instructions, so SIMD instructions, which are sort of a niche thing, but where they are useful, they are very useful, right? So you can really make decoders faster, like video or other things, or encryption stuff. But WebAssembly 3 is a much bigger release in many ways. It's a culmination of many things we have worked on, various features over, some since the beginning, actually, so 6 or 8 years. And that is more intended to bring things to the table that allows a wider range of languages to target this as a compilation target. The biggest one there is probably garbage collection, right? So for all these managed languages out there, that is a bit of an enabler. Technically, in principle, you could do it before, compile your own garbage collector, but there are some difficulties with that.
It's a lot of work. Yeah.
It's a lot of work, and it's like the kind of thing which works against the sort of safety abstractions that WebAssembly has. So you also pay some overhead, so it's never going to be competitively fast. And now we're making that a built-in feature. And then there are some other kind of things like exception handling you couldn't really do before. Tail calls is important for some languages. And then probably the other interesting one, which goes a bit of a different direction, is that we increase the address space to 64 bits. So that is, again, an enabler for, applications that need way more memory, like big databases or whatever, the so-called AI stuff.
Let's talk about garbage collection and like type references and stuff a little bit first. I guess you noted that this has enabled WebAssembly to be a target for all these higher level languages. Why is this important? Why is that helpful for either like end users or developers?
Yeah, so it gives them more choice and it supports more diversity on the platform, right? So it was actually always our goal from the beginning to make WebAssembly like the sort of universal compilation target, not being language specific at all. That is something I particularly value very high, others too. And it's kind of the mission statement of WebAssembly. Try to be universal, language independent, platform independent. So ultimately, we would like to support every language out there, be at least workable on this platform. And there's there always was this like long-term roadmap, if you want, from the very beginning, like the first release of WebAssembly specifically aimed at low-level languages because they were already present on the web. They were using ASM.js at the time or NACL, and we wanted to replace those with something better. So there were customers already, right? So that could use that. And they are an easy target. So the first version of WebAssembly targeted those. And then the longer roadmap was, okay, better support for more high-level languages. And then maybe at some point in the future, we are not there yet, better support for dynamic languages as well. So those are kind of like the three tiers, if you want, for supporting the universe and zoo of languages out there. And we're somewhere now.
It is exciting. Are you guys expecting like a pretty major uptick of developer code that ends up eventually getting compiled to WebAssembly now? Like, do you think that this will be a big kind of step forward in adoption of WebAssembly as just a target that people are actually using?
I think it will not be like a steep increase all of a sudden or something, because all these things take time, right? People have to build like the ecosystems and the infrastructure and all that. But we already have half a dozen at least of languages that target this new platform like at this point. And I don't think there will be immediately as many as they were in the beginning of WebAssembly with all the pre-existing code that could just switch over. But we definitely hope that it enables gradually more languages to run on this, and that more choices, as I said, both on the web and outside the web, right, where WebAssembly is also increasingly used.
I get my tunnel vision a little bit. I'm always thinking about web use here,
exactly.
And then some other edge cases stuff, like functions and workers.
Very hard to not think about the web.
It's probably good you have that perspective. Yeah, but I think everyone else tends to fall into this trap. You mentioned the larger address space earlier, and that's probably like a good example there. It's like for the web cases, that's probably not as big an ask, but I imagine there's a lot of non-web cases where it's like we need a larger address space. Were there any particular use cases that like you guys really felt the need to get the 64-bit address space on the table for?
So first of all, on the web, there are these additional limits that kind of the JS embedding imposes. So on the web, you will still be limited to 16 gigabytes of memory. But outside the web, there is no limit other than other platforms imposing it. And yeah, there have been users. So one is a company I worked on. They use WebAssembly in some kind of distributed computation blockchain, if you want, context where you can allow applications to do a lot of data and basically have in-memory databases. And they were always struggling with the 4 gigabyte limit and already worked around it before for years, but now it's much easier for them. I mentioned like large language models as well. There are people who want to do that on WebAssembly because of portability or, I don't know, safety for various reasons. And then, yeah, you can easily run over that as well. And I don't actually know who else, but I only know in the background that there have been lots of requests to lift this, lots of complaints that, oh, I only have 4 gigs. That's not enough.
Yeah, there are a lot of use cases like that. Portability is an interesting use case. And this is, I feel like, kind of something that's always talked about a little bit when we're talking about these kind of more agnostic targets, right? Or more agnostic platforms and like the ease of developers running stuff locally or the capacity to distribute. Is there anything in particular you think that makes WebAssembly like a uniquely good fit there compared to other technology that we've tried to push through historically?
Yeah, of course, we learned from the problems that the previous technologies had. I guess the particular ones of the Java, the JVM, and the .NET platform, right? So they were specifically designed to support like one language very well. And in both cases, there are tons of other languages that sort of compile to them, but they pay quite a price to work around the impedance mismatches. And that's definitely one thing we wanted to avoid, right? Like I said earlier, we want to be an unbiased universal platform. And the key to that is that WebAssembly is more low level than the other platforms in terms of its instruction set and object model, if you even want to call it that, because there are actually no objects. And yeah, so that is one thing. The other thing is that we also built like sandboxing as part of the module system that WebAssembly is based on as a very fundamental technology, right? So every WebAssembly binary is a so-called module, and it has imports and exports, and that's all there is. And a module itself can't really do anything. It's completely sandboxed. The only way it has access to its environment is through the imports you give it. And you have to provide those explicitly. So it's like a capability-based security model, if you want. And that makes it interesting for various people who are concerned about security and application code grabbing some ambient capabilities and just accessing something. So this is a very tight model in a way that is very simple, but has been there, not as an afterthought, but as a basic model for WebAssembly. And people like that too.
It makes me curious if it significantly reduces the exposure area for a lot of use cases, or is there any fear, I guess, of one's using a high level package and that thing ends up passing file system in, and then it like needs, for some package it has 4 dependencies deep or something, like that thing being the problem? Is there any kind of traceability on when going and finding a tool to pull off the shelf, like where this thing actually is sending these down in its tree?
You could certainly implement static analysis tools that try to figure out these kind of graphs and dependencies more easily in WebAssembly, I guess, than maybe in other languages.
It would be direct. Like, it'd be pretty easy to kind of trace those lines, I would think.
Yeah, it's a bit less easy once you talk about function pointers, function references, really, because they are more first class. So that in general requires some more advanced analysis, right? Or tables are midway there. There's this table primitive which allows you to just store an array of these function references. So if you share that table, you also share the references in it. But yeah, any such static analysis will have its limitations. But if you're following certain disciplines, it can probably do a very good analysis on regular code.
It's no worse than any other, and it's kind of
No,
a
definitely,
necessary evil.
definitely not. Like, again, somebody, you have to give your reference to the code somehow, and then someone has to pass it on. But yeah.
Were there any features in 3.0 that were focused on this, particularly like more easily leveraged on kind of this import the module ecosystem, or was that stuff pretty settled historically?
Yeah, interesting question. So one thing that might be related to the modularity aspect is the ability to have multiple memories, right? So this is really, in a way, just closing a gap that we had in WebAssembly before, where, contrary to popular belief, you could have applications with multiple memories, except that a single module could never reference more than one. Right. And that was a bit artificial because it meant that certain things are not possible. Like one tool that people use routinely is merging modules, smaller modules into bigger one. And that worked in all cases, except if they both had a memory. Then you couldn't build the bigger module from those. But with respect to security, this is also an interesting feature because you could use it to separate like shared public memory from your own encapsulated private memory, at least in principle. I don't know if that has been really applied yet in practice because some of the tooling there is a bit in the way. If you compile through something like LLVM, then it's currently very hard to use this feature because it doesn't really have support for separate address spaces. So this would be more something that like a primitive library can use internally so that you don't see it in the APIs or something. But it's definitely something that some security folks have been interested in. And it's also a good use case for, or a good mechanism for, I don't know, doing something on the side, like when you instrument your code. I don't know, you want to instrument it with some kind of logging.
Yeah.
And you do that and put that into memory, and you don't want to interfere with the code that actually is there or other codes that you share your memory with. So you use a side memory, log into that without affecting any of the other memory usages. It's just completely separate. So in a way, it's modular or safer if you want. Less interference.
Less interference, that's a good term. This seems like something that would be difficult to leverage depending on like what language you are using or end languages as a developer.
Yeah.
I have a hunch this is something you guys think about a lot, and I'm curious if you have any thoughts on like features being added to WebAssembly that may or may not be usable by a given higher level language and like how that exposes it. Do you maintain a mental model at all of, okay, this is something that will be more leveraged by a very large subset of the languages which we're trying to set up WebAssembly as a target for, versus this is only going to be one or two of the lower level kind of candidates able to use it?
Yeah, I mean, we usually try not to put in features that are too specialized to certain languages or language families, even if they are very mainstream. So in principle, I would think that all the features are useful for a sufficiently large set of languages. But then there are some features, and maybe multiple memories is one of them, that are less targeted at being used by a language on top, but more by tool chains in the middle, right? They could do something with that, like the instrumentation I talked about, which it would not be visible in the source language. It would be more something that the tooling itself can use to play tricks.
Yeah, that's true. Yeah, you have some other module in the middle, or there's some like compilation step or something that does this instrumentation layer, or it's part of your deployment
Things
platform.
like that, or some low-level libraries that you build that are sort of bindings and do some magic under the hood that are also not expressed in the source language, but more by the compilation pipeline or whatever. There are various things you could imagine happening there. Yeah, and I guess that is multi-memory in particular is in that category. Trying to think if there are other features that are similar to that. Can't really think of many.
Yeah, at least nothing in the notes here that seemed quite that way. Maybe tail calls, but I would think that would mainly be up to like the implementers, like of the kind of.
Yeah, so tail calls are, so for certain source languages, they're essential more or less, right? Like especially functional languages. But there's a very famous paper by Matthias Fassler who argues that if you want to do pure object-oriented programming, you also actually need tail calls, otherwise it will not work. But so that is one use case there. It's not like necessarily like an explicit feature in the source language in the sense that there's some construct that maps to it, but that every call in position has a certain guarantee that it can't overflow the stack. And that is one use case for it. The other is internally, again, in more like runtime systems. Actually, people use it a lot, especially when you have complicated engines, like a JavaScript engine itself, for example, uses a lot of tail calling internally to do all these like inline caches and stubs. It jumps into that, then jump to something else and replace themselves with something else. You do a lot of that with tail calling so that you don't like increasingly grow the stack. So that's all hidden away from the user. They don't really have to care about it, but it's enabling these techniques. But I'm trying, like, one other feature that is not new, but you could argue is also more for really the tooling or the compilation pipeline, is actually tables. Tables is not something you would typically expose in the programming language. It's a feature to enable certain compilation technique.
Can you explain a little bit to end users again, who probably aren't writing this stuff themselves, but relying on something? What are tables and why do those help optimize?
Tables are... So another thing that people sometimes believe, which is not true, is that okay, WebAssembly has memory, and that's all there is to it, right? To state. That's not actually true. There are two other things. One is globals, which are what you think they are, and then this more weird thing, which are tables. And with WebAssembly 3.0, tables got a bit more general, and basically they're a way to store references in some way that allows you to index them with numbers. Any kind of references. So originally it was just function references, and that was put in because that was the only way to basically imitate something like C function pointers. So they provide an address space for code, if you want, through this extra indirection through a table. Because one thing we don't want to do for security is we don't want to expose code addresses, obviously. But then how do you do pointers that you want to store in memory where they are exposed, right, as some numeric thing? So you still want to have some numeric thing. And the way it works in WebAssembly is you store a table index, and then you do the indirection through that table. And that is bounce checked. But all you see is that index. You don't see a code address, so it can't be abused for any kind of like attack, security relevant attack. And with WebAssembly 3.0, that is generalized that you can also use it for other kinds of references if needed. So basically, the memory is the storage for numeric data, which is completely transparent. And the table is a storage for reference data, and references are completely opaque. You cannot observe their representation, their bit pattern for security reasons, right? So you cannot store a reference in memory. Whenever you need a reference, need to hold a reference in memory, you have to go through this table indirection so that you turn it into an index. But that's very much a mechanism that a compiler will use internally, then exposing it to the source language user, right?
Were tables a natural abstraction there for most of them, or is that something that they even have to worry about that much?
The idea of using tables to implement function pointers that originates from ASM.js that already used this kind of approach to compile C, and that way it was clear to us we needed something equivalent, and tables was just the easiest. So they were using arrays, but tables are like a slightly more static version of that. And so it was very natural to have that.
I want to talk about the deterministic profiles and exception handling. Which one of those do you think would be more interesting to jump into first?
Yeah, I guess exception handling is definitely more interesting to users.
Where were we at before, and what does 3 add?
So exception handlings like GC was one of the features that was really in the making for many years. And exception handling originally was put in or desired or proposed because that was the one thing from C+ that we could not express. So the C+ compilation pipeline, when you actually turned on exceptions, which almost nobody does in practice, but there's at least one major company that does that, and they were pushing very hard. So previously, that was compiled by basically when you have an exception handler in C++, it would be compiled to, I'm calling out to JavaScript. JavaScript installs an exception handler. Then I'm calling back into WebAssembly, right? So it would ping pong across the boundary just to set that up, which you can imagine is like neither efficient nor very robust. And yeah, so there was the desire to have a mechanism built in that allows you to compile these things. And other languages obviously want that too, because exception handling is pretty common these days in other languages.
Is it mainly a performance increase then for like end users, for developers? Is that kind of the big thing, or was there not much exception handling support happening at all prior to this?
Yeah, prior to this, you had to do this gymnastics to make it work. And I think for low-level languages, as I said, C++, they are not used very much. So that was sort of okay for many, but it was definitely a roadblock for other languages, more high-level languages wanting to compile because they use exceptions. And then, yeah, they would also have to do this game somehow. There are various ways to do that. You could also do a whole program transformation with continuation passing style, but that's also very expensive, right? And yeah.
You probably get into all kinds of other problems too, the more hacky, like shim stuff you do there versus, especially, like languages that tend to use exceptions as control flow and all this stuff.
And the interesting thing is that the use of exceptions, although the mechanisms are all relatively similar across languages, the sort of culture of using them is quite different. So some really only use that for what they were originally meant for, like exceptional situations, like a signal and error, essentially. But others really got into the habit of using them as a control flow feature, just like you can shortcut some loop or call chain. I don't know if you found your result or want to abort or something.
Or try to do this thing. If you get an exception, then go do this thing instead, kind of stuff.
Or something like that, exactly.
I do think the deterministic profile stuff is like academically very interesting, if nothing else. Can you explain a little bit about why this kind of consistent execution is useful in certain contexts, or why people are asking for this?
So this is actually essential for some users of WebAssembly, but this is, so what is different here is this is not something users want, but providers of a WebAssembly platform. And the obvious example is there are various blockchain systems now that run WebAssembly on the blockchain, right? And blockchain means that you're relying on consensus for replicated computation, which means your computation must really be deterministic, otherwise you won't reach consensus in any useful way. So you really want reliable behavior to be the same everywhere and every time you execute it. So they absolutely need deterministic behavior. And previously they kind of hacked around it themselves. For example, WASM time had a feature that allows you to normalize nans, right? So prior to WASM 3.0, nan bit patterns was the only piece of non-determinism in WebAssembly. But with relaxed SIMD, we got more of that and crossed certain red lines in a way, if you want. And so there was this pressure to offset that by the ability, at least define what deterministic behavior would be. So it's like a subset, if you want, of the language in terms of behavior that is fully deterministic. It doesn't miss any feature, but it allows less behaviors. So it's well defined. And if you build such a platform, you now have a spec to go to and, okay, this is exactly the behavior I'll get. And maybe engines provide that for you and implement it. And everybody agrees on what it means. That's really...
You mentioned the relaxed SIMD stuff. Why did that introduce some more non-determinism? What were the mechanisms in there that made this stuff not consistent?
Well, that was a very controversial feature in many ways. So the original philosophy of WebAssembly was we only put in stuff that is in the intersection of all major CPUs nowadays, right? But with SIMD, you're getting closer to the cutting edge. And people, especially in machine learning, they really want to use the cutting edge performance features in SIMD. Unfortunately, the hardware vendors can't get their shit together and agree on anything. There are all similar instruction sets they all have, but they all disagree on edge cases and what happens when... right? And so we wanted some way to underspecify that, essentially, that all the behaviors are allowed and you don't have to normalize, which would basically ruin the whole point of using SIMD in the first place, right? If you have to normalize the result after the fact. And there are two ways you could do it. Just one would be random, non-determinism, with nans, you simply don't say what happened. Every time you execute something and it is in one of these undefined edge cases, you could get a different result. For some reason, that's not what they wanted. They also wanted some additional guarantee that when you execute certain instructions that they behave consistently with themselves, at least. That made the story a whole bit more complicated. You now have a whole other dimension to worry about. It's not just non-determinism, it's actually implementation-dependent behavior when you look closer. And that is something I personally think is a mistake for something like WebAssembly that tries to be portable, because it blesses code that really tries to depend on that implementation.
Right. It leads to a false expectation a little bit.
Exactly. Yeah. But yeah, that's where we are, and that's how it got there. And so far, I think there was one company who pushed a lot to get that in. Now it seems there aren't that many users, at least, although it has been available for a couple of years already. So I don't know. Yeah, we'll see about it.
Yeah, that's a tricky one. WebAssembly is such a broad kind of noble goal that has all these different use cases and all these different people want it for different reasons. And I'm sure that there is like a lot of tension between the different contenders here.
Conflicting goals.
How do you guys like balance that? How do those discussions go?
With heated discussions.
Yeah.
Yeah, I mean, sometimes the seniors among us, like who have been there from the beginning, point out that, oh yeah, but that was not the idea of WebAssembly when we started, and that is often an argument. Then okay, but maybe one thing that is actually missing and that is making some of these discussions difficult sometimes, or people are surprised that we don't want to do something, is that we don't really have any written down set of what is the philosophy of, like, the rules of the philosophy of WebAssembly, like the Zen of Python or something equivalent. And yeah, maybe we should have that, but maybe also it might not be a good idea. Maybe we want to stay flexible. I don't know. But usually, yeah, we have the working group or community group meetings, and these are sometimes topics for heated discussion. And usually it then comes down to either we can find some compromise that we can converge on, or the feature will not get in. And there have been a couple of occasions where we rejected features because we didn't feel they are fit the spirit of WebAssembly. Like, I can give one example that there was a proposal for string built-ins, putting in strings as a primitive reference type. But that whole proposal was essentially driven by JavaScript interoperability. So the whole design was around, okay, make it cheap to pass strings back and forth from JavaScript. But that would also mean that you essentially standardize JavaScript strings, which are not particularly well designed thing, first of all, and also not necessarily what the majority of languages need. It would be a very JavaScript specific feature. And that's why some of us thought that, no, let's not do that. And that's why what we ended up with here in 3.0 is instead these string built-ins, which are more on the boundary. They're not a primitive part of the core WebAssembly instruction set, but something that certain platforms, those that have JavaScript, supply, and you can import it as primitive. So that is pushing it to the embedding than the core. That makes more sense, and that not everybody needs to support it.
Let's use this kind of the string reference as an example. Where are these asks really coming from? Who is the implementer? Who is the person that's like, this would help our use case a lot, or would give our end users eventually a better experience?
There are some things where we just, okay, let's fill some holes we left in the original design, like multiple memories was one of that. We always anticipated that we will eventually fill this hole, but originally we left it out for simplicity to get off the ground more quickly. So that is something that comes from within the CG. Then I guess the most common case is language implementers, those who are close to the community group, and they say, okay, I'm doing this kind of thing here, and it turns out that I could really make use of this feature. Then there are a bunch of things where you just know that this is a kind of general mechanism that many people need. Like GC is an example of that, right? It was always clear that we needed something like that. Tail calls as well. There wasn't any specific pressure there from already existing users because it's sort of a chicken and egg problem. They wouldn't even consider targeting WebAssembly without that feature, right? So in some cases, the CG itself pushed forward some of these features to solve this chicken and egg problem. But usually this is also driven by some users in the background who maybe want to use a certain language which doesn't currently compile to WebAssembly, and this is what they need to make that happen. So GC was also in that kind of category. Yeah, that was the desire, for example, within Google to use WebAssembly for Sheets and other of their applications, which are all run in Java. So they want to compile Java and as well Kotlin to WebAssembly, so they needed some GC support. When there's some big player there saying we want this, then that is what makes at least engine providers like Google be willing to do the work for their customers, essentially, right? Because the whole process is anybody can propose something, right? That's not the problem. And you can push it through the process quite far without having to do a real implementation. But at some point, our process requires two production engines to implement a feature before it can be standardized. And in practice, that means two browser vendors. So usually that's now that Edge is no longer its own thing. That's usually Chrome, V8, and Firefox. They are usually, when they both agree, okay, we have enough interest in implementing this, then you can get a feature forward. If they say we don't care, then you have a problem.
As we said before, like we shouldn't only think about web, but where most of this code is running is probably those two. Now that 3.0 is out, have you seen any kind of adoption making it through into production like workloads that you think are like having high impact? Were there any cases that you could think just a standard user is like, oh, that's this tool you use all the time. Now that we have 3.0 out is probably more efficient because now they're targeting WebAssembly for something like this. Have you seen tracked or seen any of those cases roll all the way out to end users?
Yeah, I mean, GC is already shipping everywhere and has been for a while. I mean, most of the features have actually been shipping for a while, so applications have already been using it for a while. And GC, yeah, when you use Google Sheets or whatever, you run WebAssembly GC.
It's a little bit snappier now. The memory maybe isn't quite as bad.
I'm not a user myself of that, but I don't know if I can pull out other examples out of my head right now. But
it's a tough question.
Yeah, I mean, since most of these features were desired by certain parties, they probably already use them, right?
Yeah, get picked up pretty quick. Do you expect that this kind of like adoption across the browsers and engines is pretty quick? Like people had a lot of these in place that for what they could already and stuff comes along quickly, or is that kind of a slow process?
I think you can see all sorts of paces there. There are early adopters, there are very slow adopters. I don't know if you can make like a general statement about it. And usually it's proportional to the proximity with a working group. Like there are some people who really care a lot of it and want to push it forward rather faster than slower. And they, of course, adapt it as quick as they can. But then there are people who, for which it's really just a tool on the side and they don't care that much and don't stay up to date with what's happening necessarily. So.
Yeah. Which, I think is reasonable. You're gonna have all people that are like, have some specific use case and like, okay, our thing is done. We don't really need that much new stuff anymore. It's probably fine. What do you think will define 4.0? Is there anything in particular that's taking shape there that looks like it's the definitive thing people want or needs to get done next?
Yeah. First of all, I'm not actually sure the next one will be 4.0 because we're now trying to basically bump the minor version with every feature we merge and
see
a quicker release cycle. But that aside, I think the major two things that are still on our roadmap, or maybe two to three things. So one that has been in the making for ages as well is actual threading. And that, for various reasons, has been delayed many times. It's also has been shipping for I don't know how many years in all the browsers, right? But the first delay actually happened due to Spectre. That was like right when it was supposed to ship. Spectre happened and everybody panicked and unshipped it. And since then, now it's mostly blocked on specification and memory model questions, which I hope we will get over next year. So that is a big one, I think, so that you can actually port P threads essentially to the web, for example, right? And the other one that is filling another kind of gap for something that you can't currently compile well to WebAssembly is the stack switching feature. So this is also something we have been working.
What is that? I don't know.
Right. So one thing that you can't compile easily right now is any sort of interesting control abstractions. So let's say green threads, lightweight threads, async await, sometimes generators, effect handlers, coroutines, all these things. All they have in common is usually that you want to suspend some computation and code it there and
do
resume another one. For that, under the belt of the implementation, what you usually do in native code is you have multiple stacks and switch between them, right? So you can just suspend one stack and continue working on the other. But that is not something you can currently map to WebAssembly. So that is a feature that enables you to do that, but keeping with the kind of safety model for WebAssembly where we don't actually expose stacks as a first-class thing because that would be unsafe. We have to make it a bit more high level, and the way it's going to be exposed is through, essentially, we give you delimited continuations, if you know what that is. So yeah, you can think of it as coroutines, essentially. that you can pass values in and out of.
Are there any languages in particular where that won't work well for? This is like a very big question.
The question to ask is, what are the languages that benefit from this, right? You can always not use the feature. That's fine, right?
That's true. That's true. Yeah.
Yeah. One example I mentioned was green threads or virtual threads. For example, if you want to build a fully functional Java implementation, right now there are Java compilers, but they're single-threaded essentially. Or use system threads, which especially on the web are very heavyweight and not necessarily a good map for other things. Java 21 has this notion called virtual threads, which is essentially something similar, right? So if you wanted to be able to compile that to WebAssembly, that's the kind of feature you need. Or if you want to be able to do async await, essentially, there are ways to do that without switching stacks, but they don't scale well. That's what JavaScript engines do, for example. They do this kind of automaton transformation, which is really a form of continuation passing style transformation. But that is costly and changes the ABI and all that. So with stack switching, in principle, at least, that can be much more efficient. You could also compile generators with that. Another more advanced feature, which some modern functional languages have, is what's called effect handlers. So they're essentially a form of exception mechanism where you can resume. You can go back to the point that yielded the exception or erase the exception. And that is actually where the mechanism we're implementing took its inspiration from, this sort of abstraction. So you can go back there. And then there are, of course, like the more traditional continuation features. If you scheme or Lisp or something, they have call CC or other forms of prompts and continuations. If you want to compile those, again, you need this feature. So basically every sort of control abstraction in modern languages, and most of them have many, will be able to compile down to this kind of primitive in a way.
You put it more succinctly than I could ask the question. Are there any other features that you kind of wish you'd been able to get into 3 that are next other than this stuff, or are those kind of the front runners?
Yeah, those are the front runners, definitely. So the big ones. And then there is smaller stuff, but none as interesting. There will always be smaller things we add on the side, like certain instructions, whatever. But in terms of big features that allow you to do things that you can't do right now, those, I think, are the 2 big ones.
Nice. Yeah, cool. We should wrap here, but before we do, if people are interested in this stuff or they want to see how either stuff's going on the implementation side or in the WebAssembly side itself, like where would you recommend people jump in to get involved?
It depends on how deeply you want to get involved.
How deep you want to go.
So the WebAssembly community group is completely open, right? So that is basically all the proposal discussions and everything that all happens in the open on GitHub. So if you really want to know, you can just follow the repository. So that would be, there are several, but if you look at WebAssembly.org, then they will point you to that. And you can also join the community group and participate in the actual meetings. So the main group has a bi-weekly online meeting, 1 hour on Tuesday night or morning, depending on where you are. And once a year, roughly, we have a face-to-face meeting then. The next one will be in Munich in this month, actually, in 3 weeks or something. So, yeah, in principle, anybody can show up there. All you need to do is to register your email with the W3C, which is our legal roof for doing this standardization. And the only reason to do that is to get legal concerns out of the way that somebody might pull some patent card at some point.
Yeah. Gotcha.
Yeah, if you really want to know what's going on, then you can attend the meetings, or you can read the meeting notes, which will also be on one of the repos posted there afterwards. But that might give you more than you ever wanted to know.
How about like on the implementer side? Like, oh, whatever, I'm writing a specific language. Go find the people that are doing compiler implementation step. Like
you mean the compilers targeting WebAssembly? Or?
Yeah, exactly. The people writing those.
All the producers.
So, yeah, sorry, forgive my term.
Consumers and producers. Consumers compile WebAssembly to native code, which are the engines usually. Yeah, so the producers, I don't know if I wouldn't know that there's like a forum where they all meet. This is, I don't know, just many different groups working on some compiler. I don't think there's any centralized thing other than the WebAssembly community group meetings themselves, where some of them at least regularly show up.
I'm sure some good Googling or chat or LLM prompting could point you in the direction.
Okay, I'm interested in this particular compiler. Maybe look for that and see if they have resources about it. There isn't any central thing.
Yeah. Which is fair enough. I guess it's probably difficult with as many moving pieces as there are all the time, and like different people targeting stuff. Yeah, but very cool. I feel like we covered a lot here. So thank you for letting me pick your brain a little bit, Andreas. I appreciate it. I know you've got a lot going on. Your time's pretty valuable right now, so I do appreciate it.
Thanks for having me.
Of course, it's great chatting.